Okay, welcome to our lesson on properties of proportions and geometric mean. We're just going to look at a couple more ways you can manipulate proportions today. So I start out with A over B equals C over D, and I can change that so that it's A over C equals B over D. You can memorize that idea, or you can just always remember that if we cross multiply, we can manipulate a proportion any way we want. So if I take those arrows out of there, if I want to cross multiply, I would just take A times D, cross multiply again, and I have B times C. So if I divide both sides by C, and then divide both sides by D, when I do some canceling out, those D's cancel out, these C's cancel out, and I'm left with the A over C equals B over D. So it's nothing that you can memorize this, or you can always just remember to cross multiply and divide however you need to divide. For this proportion, we take the denominator and we add it to the numerator. Take the denominator and add it to the numerator, and that still gives us a proportion that maintains its equality. Okay, so you can go ahead and write those down in your notes. Geometric mean of two numbers is set up, first of all, in a proportion such that A over X equals X over B, with X being the geometric mean. We can find X by taking the square root of the product of the other two numbers. Okay, so if we're going to find the geometric mean of 8 and 12, we have this idea, 8 over X equals X over 12. So X squared, just cross multiplying, equals 8 times 12. X squared, or X equals the square root of 8 times 12. So you can see, again, you can memorize this formula, or you can just remember how to set up the proportion, and you can cross multiply again. So X is equal to the square root of 96. If I want to reduce that radical, I find the biggest square root that divides into 96, and that's 16. 16 times 6 is 96. Square root of 16 is 4, and the square root of 6 stays the same. So that's the geometric mean. So what we're saying is that 8 divided by 4 square root of 6 is equal to 4 square root of 6 divided by 12. Okay, examples. True or false? S over 10 equals 15 over T. Okay, so we're given that. We had a property at the start that said I could go straight across and rewrite this so that S over 15 is equal to 10 over T. But there's no way I can get this to be S divided by T, no matter how I cross multiply. If I take ST is equal to 150, or 15 times 10, I can't get T to be in that denominator. If I divide by T, they cancel out. So this is a false statement. Okay, the next one, 3 over X equals 5 over Y. If I add the denominator to the numerator for both, leaving the denominators the same, that follows our fourth property of proportions. So this is a true. And using proportions to solve a problem, we're given that MQ, so that's this whole length, which if we add this up is 21, over MN equals LQ, which we don't know, over LP. So I can set up that proportion. So I have 21 over 6 is equal to LQ, which we don't know, so we'll leave that a variable, over LP, which is 5. Go ahead and cross multiply, and I get 105 is equal to 6 times LQ. And if you want to put just one letter in there for a variable, that's okay too. Just remember what it stands for. So I'm going to go ahead and I'm going to divide by 6, and I get 17.5 is equal to LQ. So be careful, because that's not what we wanted. What we wanted was PQ. So that's just a part of this. So if 17.5 is the whole thing, I'm going to subtract the 5 that is LP, and therefore PQ is equal to 12.5. Okay, last few examples. Find the arithmetic mean between 32 and 8. Arithmetic mean is what you've been finding since elementary school. All that means is average. And to find average, remember we add the numbers up and divide by however many numbers there are. So in this case, 2. So we have 40 divided by 2, and that is 20. So the average, or the arithmetic mean, is 20. That's all based on addition and division. The geometric mean, remember, is the square root of the product of the two numbers. So I have 32 times 8, which is 256. Take the square root of that, and I get 16. So the geometric mean is 16. Geometric mean between 12 and 20. Again, I'm going to take the square root of 12 times 20, and that's the square root of 240. So again, that's a decimal, but I want to leave that in as exact form as I can, so I'm going to leave it in radical form, but I want to reduce it. So I try to figure out what number can be divided into in there evenly. So let's say we just guess and we say 4. So if I have 4, I have 4 times 60, and that equals 2 times the square root of 60. But that seems like a pretty big number, so I'm wondering if another number won't go into it. So let's try 4 again. So I leave my 2. Now I have the square root of 4, and 4 times 15 gives you 60. So I just continue to reduce it. It's like reducing a fraction when you're not sure what the biggest number is that will divide into it, and we just keep doing it until we find that biggest number. Now 15 doesn't have any perfect squares that will divide into it, so at this point we are done. Alright, and the last question here in red means that you're going to do a little research on your own to see if you can find out the difference between the arithmetic mean and geometric mean. You can explain the process just by looking at what we did above, but this is the one you might need to do a little research on. Why would we use the geometric mean instead of what we know already as the average? So maybe you can Google that, do a little research, and see what you can find. And that's it. Thanks for watching.